Hey guys, welcome back to another video, and today we'll be learning about exponent rules and how to efficiently use them. And so what do exponent rules actually mean? So what it means is just basically another tool in order to simplify some simple equations. And today here are some exponent rules for algebra or for any other parts of advanced math that you might need to know. And so the first rule we will learn is that x to the n times x to the n is equal to x to the n plus n. Now, what does that exactly mean? Now, what it may mean is that in an example, if we use x to the 2 times x to the 3, we will see that if we use this rule, we just get x to the 5. But why is that? Well, it's simply because of how you can simplify the equation. And so let's say if you have x to the 2 is just x times x. And then x to the 3, when you're just multiplying them, just x times x times x. And if you see here, if you count how many x's you have 1, 2, 3, 4, 5 x's, which means that this equation is just equal to x to the 5. Another rule that you might stumble upon when you're doing exponents is when you see x to the n divided by x of some m to a certain number. And now what this rule essentially means is just that it will be x to the n minus m. Now why is that? Well, let's look at an example. Let's say you had x to the 5 divided by x to the 2. Well, with the rule, you can safely assume that this is just x to the 5 minus 2, which is just equal to x to the 3rd. But why is that exactly? Because you could also write it up like this. And if you see here, you can safely assume that, just like x to the 5, there's 5 x's. And then on the bottom, there's 2 x's. And then from there, you can simplify, which just leaves you with 3 x's. So that's why the quotient rule works as well. This is another rule that you might also want to know if you're starting on algebra. And so that rule is when you have an x and let's say some sort of a multiplied to some sort of b, what this essentially means is just that this is just going to be x with a times b. And so let's look at an example as to why is that. So let's say you had x to the 2. Just pretend that's a 2 times 3. So with the equation, it would just be x to the 6. Now you might be wondering, why is that? And you might as well just look at the 2 times 3 and be like, well, that's just 6. But there's a little bit more, to that other than just looking at the numbers and multiplying them together. And so what this x to the 2 times 3 basically means is that you have 3 of the x to the 2. And essentially, you can again break these apart. And as you can see from here, you have 6 x's, which makes for x to the 6. And I understand you might be having a hard time with that. I also had a really, really hard time with that learning algebra. Now, there's also another rule called the power of a product rule. And so let's say you had x to the n times x to the m times something, let's just say a. This would just mean that this would be x to the n times a times x to the m times a. Now, but what does this mean though? And with different variables, I will be able to show you that. So let's say you had x to the fourth times, let's add in a new variable, y to the fourth power. Now, if you be able to do this, you would know that with the power of the product rule, you would just do x to the fourth times 4, which is x to the 16. And then you have the y to the fourth. Now, essentially, the y to the fourth is just the y to the 1. And then with the rule that I previously said, you could just multiply it by 4. And so then, by then, you would have x to the 16 times y to the fourth. Since for different variables, you don't mix them in, or if you want to, you could also just do this without writing the big sign in the middle. You could also just do that. Now, there's another rule. There's a lot of rules. I understand that. Don't worry. This will all be helpful. But there's another rule called the power of a quotient rule. And let's just say you have like two random letters, like, I don't know, Q and Z. Why not? Multiply to like a W. What this essentially means is that even if you had in the fraction, you have to distribute the W and make them to the power of both Q and Z. Now, how does this look like with normal variables? Because you nerds like to use x and y a lot. So, let's have x and y to the 2. What this essentially means is just that we're going to produce that power of the 2 to both x. To both x and y. And so essentially what this equation just becomes is just x to the 2 to y to the 2. Now guess what? If you have actually been paying attention to the video and instead of just skipping through all the time that you needed. No, I'm kidding. Don't do that. Please don't get off the video. But here's another important rule you need to know. Let's say you had Q again. Get it to the 0. You have to remember that anything to the power of 0 is just 1. You may be wondering, why is that? Well, let's say you had x to the fourth. And you divide that by itself. Well, you might say something divided by itself is always equal to 1. And that might be the simple answer to you, but why really is that? Well, if you refer back to the other rule, where let's say you had x to the n divided by x to the m is equal to x n minus m, you would assume that you could just do x to the fourth minus 4, which is just equal to x to the 0, or which is just equal to 1. Reason why that is because, well, it is kind of simple. You're just dividing it by itself. And from there, you just have 1. But when you take an x, and let's say you have it to the exponent of 6 or 8, if you divide it by that same exponent, x to the 8 divided by x to the 8, what you're essentially doing is you're just doing x to the 8 minus 8, which is just equal x to the 0. And anything to the 0 power is just equal to 1. And so that's a very important rule to remember. Just remember it. Now, there are 2 more rules that I must teach you in order for you to become great mathematicians, which I'm not, unfortunately. So, there is a rule called the reciprocal rule. Let's say you had x to a negative n. It would just mean that you have x 1 over x to the n. And let's say you had an example. Let's say you had x to the negative 2. This would just be equal to x to the 2, but just 1 over x to the 2. And you might be wondering, well, that's kind of confusing, and it is. It really is. But here's a solution. So let's say you had 1 over x to the negative 2. What would that mean exactly? Well, with the reciprocal rule, you would just know that it would just be 1 over x to the 2. But then this is just a fraction. But then what you could do is just keep change flip. So you keep the 1, flip the x to the 2, and then you just get x to the 2. And so that might be a simple proof if you're being confused with any reciprocal identities. And then you have I think it's called like the root rule or something like that. It'd be like if you had x to the m rooted by n. So essentially what this just means is it says that it's just x to the m over n. And how would that look like in an example? So let's say you had x to the 5 over 2. What this essentially means is just that you have x to the 5 with a root over it. Or if you really want to be fancy, you could also have just root x, and outside parentheses, you get the 5. And they would make the same thing. Just don't make the crucial mistake in switching them or to just lollygag and not pay attention to what you're doing, because I taught you this neat trick. But anyway, these are some exponent rules that you must know if you want to do good in algebra or in higher math. Thank you for listening. Please subscribe to my channel. Like if you liked it. Thank you. Goodbye.